8.3 Special right triangles. Why are they special? Two different ones, 45, 45, 90, 30, 60, 90. There is a link between both of them, as you now know, and we'll see how those two different triangles, without using a calculator, you can find a lot of information about them. Okay, so going back to what we did, here's the 45, 45, 90 using Pythagoras theorem, a squared plus b squared equals c squared. You will see that what happens is h is equal to whatever the side is multiplied by root 2. The click is two different angle sizes, root 2. So here's example 1. The leg is 6. Well, if the leg is 6, both legs will be 6 because it's 45, 45, 90. And if you use Pythagoras, 6 squared plus 6 squared, square root it, etc., you're going to finish up with 6 root 2. So whatever the leg is, the hypotenuse is also always the leg, the value of the leg multiplied by root 2. In B, now we're told that you've been given 9 root 2 as your legs. Well, don't forget it's 9 root 2 times root 2. Root 2 times root 2 will just cancel down to an ordinary 2. 2 times 9, 18. Okay, this time working inversely, this time you are told that the hypotenuse is 12. Well, then to get to the side, instead of multiplying by root 2, you are dividing by root 2. Well, as you know, you can never have a radical at the bottom of a fraction, so you multiply top and bottom by root 2. So 12 times root 2 times root 2 is root 4, which will cancel down to root 2. So here's your sum, and then just simplify 6 root 2. Where's the link this time? Well, if the hypotenuse is 12, the side is half of the 12, which is 6, multiplied by root 2. So if your hypotenuse was, say, 20, your answer will be 10 root 2. Okay, let's put this into practice. So example 1, which is question number 1, your leg is 5. You need to find the hypotenuse. Remember, it's multiplying by root 2, so your answer is just purely and simply 5 root 2. Simple, easy, don't need to simplify it. Don't need your calculator, leave it as a radical. Question 2, slightly different. What we've got this time is 14, and don't forget we've got to divide that by root 2. Can't have a radical on the bottom, so you're multiplying both sides by root 2. Okay, so you're going to finish up with 14 root 2 divided by 2. These two guys will simplify down, 7 root 2. Going back to what I said, half of the hypotenuse multiplied by root 2. The second of the two special right triangles, the 30, 60, 90. And what I'm going to do is I'm going to actually draw freehand, obviously, A, B and D. So this is A, B, D. And don't forget, if BDC is a right angle, this must also be a right angle. They've given you this is X and this is 2X. So now let's put that into words. The AD, which is what this guy here, will be 30 degrees. Okay, the smallest side will always be opposite the smallest angle. So this is often referred to in textbooks as the shorter side, or the shorter leg, or SL. Okay, obviously you know the hypotenuse is the longest side opposite the right angle, but let's have a look at the link. If the shorter leg is 1x and the hypotenuse is 2x, then you can see the link between the shorter leg and the hypotenuse. You multiply by 2. Okay. Now, let's have a look at the calculations they've done here. By using Pythagoras, what they're asking you to find is whatever A is. Well, if you have a look at what A is, it's whatever X is, which is the shorter side, multiplied by root 3. Okay, so this is the A part. Well, this is often called the longer leg. Okay, or LL, longer leg. Okay, and as you can see now, whatever the shorter leg is, you multiply by root 3. So everything goes back to that shorter leg. So work out the shorter leg if you can, and then the longer leg and the hypotenuse becomes a lot easier to calculate. And again, as you can see for example 3, the 30, 60, 90, find x and y. Again, whatever the shorter leg is, here's 60 degrees, so this guy here must be 30 degrees, which means that this is the shorter leg. Well, the difference between the shorter leg and the longer leg is you multiply by √3. If you're going backwards, you divide by √3. You know you can't have a radical on the bottom, so multiply top and bottom by √3, and you finish up with 5√3. Again, let's have a look at the link. The question was, or the size given was 15. Your answer for the shorter leg is 5√3. 3 different angles, so you could do 15 divided by 3, which will give you your 5, multiply it by √3. Quick, easy, look for tricks like that in mathematics. So let's have a look at question number 4. Okay, 60 degrees, so this is the longer leg. This must be 30 degrees, so y is the shorter leg. Okay, well, you don't have to go alphabetical, so let's find y first. Y is whatever the hypotenuse is, divide by 2. Half of 16, so we've got 16√3 divided by 2, which is going to give you 8√3. So there's the size of the shorter leg. Now let's find whatever x is. Don't forget, that's the longer leg. Whatever the shorter side is, you multiply by √3. So you've got 8√3, and you're going to multiply that by √3. Well, √3 times √3 will give you 3. 8 times 3 will give you 24. Okay, keep the math simple.